Good morning. My name is Clifford Ngomani, and I'm the Deputy CEO of the National Research Foundation, responsible for what we call National Research Infrastructure Platforms. And iThemba Labs is one of our national research facilities. I will have the pleasure of piloting the program this morning. Honorable Minister of Higher Education, Science and Innovation, Dr. Nzimande, the Chair of the Board of the National Research Foundation, Prof. Musamo Shabela, and NRF board members who are here, Director General of the Department of Science and Innovation, Dr. Phil Mjwaha, and the executive from DSI, the acting DG of the Department of Higher Education and Training, Thembisa Fuchane, Chief Executive of the National Research Foundation, Dr. Fulufelo Nelwamondo, and NRF executives present, Vice Chancellors, Deputy Vice Chancellors, and other leaders of our higher education institutions, leadership of both private and public health organizations and facilities that are present here. Distinguished guests, ladies and gentlemen, good morning. It's my honor and privilege, actually the NRF's honor and privilege, to welcome you to iThemba Laboratory for Accelerator-Based Sciences, or iThemba Labs as we call it. It is one of the 5 national research facilities managed by the National Research Foundation. As part of our pursuit of excellence, each one of the national research facilities is implementing what we call a flagship research infrastructure project, which is meant to enable first-class research and innovation by the research community of South Africa in their respective science domains. We are here today for the inauguration of the iThemba Labs' own flagship research infrastructure project, namely the South African Isotope facility. We'll be hearing several presentations this morning, tracing the history and the business case for the project and the critical impact it is envisaged to make in an important area of our nation's health, that is to do with the imaging, diagnosis, and treatment of cancer. It is a celebration of our country's scientific and technical excellence that we've been able to bring a project of this size and complexity to fruition. We shall see firsthand after these presentations this morning when we go about on a tour of the facilities to see the main infrastructure that we are here about today. So we shall see firsthand the results of years and months of hard work and dedication by our engineers, technologists, and construction specialists and partners, and all the supporting functions within and outside of iThemba Labs and the NRF. Most importantly, we shall see evidence of the national science system leadership by our Ministry of Higher Education, Science and Innovation, in this case with the Department of Science and Innovation at the forefront. But let's start with some first things first. In a facility of this nature, health and safety is of paramount importance. So just a quick safety briefing. In the event that we have to evacuate for any reason, unlikely event, as they say on the plane, that we have to evacuate, the 2 doors at the back there are the doors that we shall use, and our principals at the front. There is an exit right behind me. The facilities are outside the door to the left, should anyone need to utilize those. Just as a point to start, we have a number here of nuclear physicists, radiation science specialists, nuclear medicine people. So if the room does get a little bit warmer, please don't be alarmed. A more specific safety announcement will be done just before we move out of this room, and also at the time that we shall explain what follows after the speeches. So to kick us off this morning, without much waste of time, I would like to call upon the Chair of the Board of the National Research Foundation, Prof. Musamo Shabela, to deliver the message from the NRF.
Good morning, colleagues. Minister, We are very honored this morning to host you at iThemba Labs. We are honored, DG Film Jocha, to have you join us as well. We have a few members of the NRF board that are also present here to provide support and to celebrate this milestone here. We have the Chief Executive of the NRF, Professor Faure, who is here as well, and other members of the executive of the NRF that we work with as the board. We've got our very new Managing Director of iThemba Labs, Dr. Victor Chivase, who is here, who started Minister on the 1st of June. Apparently, as Minister indicated, he's still under rep. We're still unwrapping him. We are honored to host you, ladies and gentlemen, members of the higher education sector. I've seen some vice chancellors and deputy vice chancellors who are present here. We're very excited to host you and looking forward to engaging with you today. We are very much aware, as the DCEO has mentioned, that there are stakeholders who are very much relevant to the subject of the discussion today. Our physicists, our nuclear medicine specialists, I can see some of them around today. We're very much excited to host you as well. There's a number of stakeholders, media and other stakeholders who are really important to us in terms of propagating the message, the core message of what we are celebrating today as well. You are all welcome. Ladies and gentlemen, distinguished guests, as the chair of the NRF board, you cannot imagine how excited I am. For us, as the new board, we started in December last year, and already we are kicking off with such an exciting milestone of iThemba Labs and the NRF. We have been given a mandate of making sure that the work of the NRF, the work of iThemba Labs, can have impact in society. We are not only mandated by the mandate of the board, but we are really mandated by the NRF Act to make sure that South Africa has cutting-edge research infrastructure that is available to the higher education sector, to the whole science ecosystem, in order to make sure that the country is at the cutting edge of science. We consider the NRF facilities as the NRF board ones that have to provide unique and substantial infrastructure in the ecosystem, capabilities for competitive research, and also human capacity development in science, engineering, and technology. Especially for what we are discussing today, what we are launching today, the facility we are launching today, the most important thing is that it needs to have positive impact in society. And that's where we are coming from. The science is interesting, the technology is interesting, but we want to make sure that the science, that the discovery science that happens is translated into benefit for society. This is the measure of success that we are looking at as the NRF board. Minister, the facility that is being launched today is dedicated to making sure that isotopes are available in the country and they can be available to others who need them. I am informed reliably that it is not only the biggest one in sub-Saharan Africa, but it's also the biggest one in the Southern Hemisphere. It will help in terms of producing isotopes that can be available for nuclear medicine, for imaging, for diagnosis, and for the treatment of cancer. It is in the treatment of disease, treatment of cancer, that we, as the NRF board, want to feel and see the impact in society for the technology that we are launching today, Minister. And I am hoping that for iThemba Labs as a whole, it will continue to align with the mandate that we've been given in the decadal plan to make sure that we don't only do cutting-edge research infrastructure within the facilities, but we are actually making sure that the facilities are available to the ecosystem as a whole. We are also making sure that this is linked to human capacity development so that we can have the people who are going to conduct this cutting-edge research, and also we can be able to see the benefit in society. There is a South African Institute of Nuclear Technology and Sciences, SAIF, that I'm also informed that it will be part and parcel of ensuring that we've got the necessary human capacity development program linked to the facility that we are launching today. So, ladies and gentlemen, Honorable Minister, the collective benefit and impact of the South African isotope facility, it will place not only the NRF iThemba Labs at the leading edge of nuclear sciences, research and training, but of the whole country and the continent as a whole. I would like to take this opportunity to congratulate the NRF iThemba Labs, to congratulate the NRF as a whole, to congratulate the Department of Science and Innovation as a whole, and to congratulate South Africa as a whole for the milestone that we are reaching today. Thank you very much.
Thank you, Prof. Without further ado, without much further ado, we'll call on the SAIF project manager, Dr. Leroy Stradom, to tell us a little bit about this project, to give us an overview of what has transpired, what has been done, and what has been achieved. Dr. Leroy Stradom.
Thank you, Clifford. Honourable Minister and Chairperson of the Board, it is my pleasure to give you an overview to you and all of our distinguished guests of the project, tell you about the objectives and the scope of the project. So, just to remind ourselves of the mandate of iThemba Labs as a national facility, to perform research and training into nuclear physics and material sciences using accelerators, and to produce radioisotopes and radiopharmaceutical products for medical applications in nuclear diagnostic imaging and in patient therapy. So our products currently serve an estimated 165,000 patients per annum in local clinics and hospitals as well as abroad. And the SAIF project is the starting point for increasing the production capacity for these radioisotopes, for further processing into radiochemicals and radiopharmaceutical products for distribution to hospitals and clinics, as one of my colleagues will elaborate further. So the objectives of the project, phase one of the project, is to establish a dedicated facility for the production of radioisotopes. And this was necessary to relieve the oversubscription of our existing facilities. So the benefits are twofold. Firstly, it will drastically increase our capacity for producing radioisotopes, But secondly, it will release the existing separated sector cyclotron complex to be dedicated to research and training activities. So the implementation of phase 1 of this project started in 2017. And some of the design considerations included the repurposing of some existing vaults that we have in the facility, that the utility services should be independent of the existing facility, and that a separate facility for the treatment and storage of radioactive waste materials should be established. So the approval for the project was granted by the NRF board back in 2018, and it was supported by the then Minister of Science and Technology. And we received initial funding for the project from National Treasury, from the budget facility for infrastructure, also from the Department of Science and Innovation, through the National Equipment Program and the National Research Foundation itself. Now, when you produce radioisotopes, you need some equipment to do this. And our processes involve the bombardment of certain target materials with high-energy proton beams. And therefore, the brief of the project was divided into 5 major work packages. First of all, we needed a new accelerator. And so this involves the installation of a new 70 MeV cyclotron and associated beam transmission lines. Secondly, you need somewhere to handle and manipulate the target material that you are bombarding with the high-energy protons, and therefore this required the design and manufacturing of new target bombardment stations and target handling systems. Thirdly, we had to construct a complete new infrastructure to support this facility, new utility services, and of course the radioactive waste management facility that we envisaged. We had a big responsibility in-house to produce some specialized systems in-house. And lastly, because we operate in a radiation-controlled environment and we handle radioactive materials, these are subject to regulatory compliance, and therefore the regulatory permitting and licensing was also an important work activity for us. In terms of skills that we deployed in this project, what we have in-house comprise many things: procurement and financial management, radiation safety design, magnetic field simulation and design, mechanical engineering design, electronic control systems design and integration, specialized manufacturing processes such as CNC machining, welding, vacuum brazing technologies, and project management. What we outsourced are specialized engineering design services in disciplines such as structural, mechanical, and electrical, quantity surveying and architectural design, some specialized manufacturing processes that you will see later on, and construction health and safety management. What we did as a team, together with our own staff members in iThemba Labs, as well as the various suppliers and contractors and engineering consultants, was the integration of the equipment requirements and the services required for them, as well as the construction contract management. So to have a look at the first work package, that is the installation of the new cyclotron. We developed specifications for this equipment back in 2017, 2018, and we specified the proton beam energy to be compatible with our existing range of products, but also to allow future developments. And this required quite a high energy beam. So there are very few companies in the world that can produce equipment like this. We also specified the beam intensity and other parameters to achieve the projected capacity increases that we were looking for, things such as dual beam extraction, so that we can extract beam simultaneously from both sides of the instrument. And in terms of the timeline, you can see back in 2019, we appointed a supplier for the equipment. During COVID times, this was produced and achieved factory acceptance testing. Towards the end of 2021, it was finally delivered to our site, and through 2022, it was installed into its place and assembled. And just earlier this year, we managed to produce and extract the first beam from this new cyclotron. So here you can follow the journey of the two magnet yokes through its manufacturing process and its eventual arrival on our site and installation into its final resting place, which was quite an involved engineering exercise. And many people were on their nerves during this process, just knowing that each of these pieces weigh 65 tons each. So I will not spoil the surprise of the final product. Here you will see that in the facility tour later on. So the second work package is now the target station. This is the system that will handle the target during bombardment and after bombardment to bring it into the chemical processing facilities. So the design of the new production target stations was based on an existing concept of a system that is currently in use here, but simplified to a large extent and improved in terms of its radiation shielding requirements and also the mechanical systems. So we envisaged the installation of a prototype system to enable development and testing before the manufacturing of the final production stations was finalized. So we appointed the supplier also back in 2021, and they managed to deliver the first prototype station towards the end of that year, and then in February and March of this year, the two production target stations were installed. Here you can see the prototype and some of the heavy shielding elements during the manufacturing process, during assembly of the target station, and keeping in mind that this whole assembly weighs 28 tons, that was also quite a logistical exercise to go through. Once again, the final product you will see during the facility tour. Now the third work package involves the infrastructure and the design and construction of all the services necessary for this facility. So the requirements involved civil construction works for the vault modifications, new access labyrinths to those vaults, the utility service rooms, and the separate waste management building that had to be constructed. Mechanical works included new water cooling systems, new ventilation systems, new target cooling systems, process gases supply, and compressed air supply. Electrical works for the new mains power supply and distribution up to 3,000 kVA, a rotary UPS system, fire detection and suppression, building management services, and control systems automation and integration. We appointed our consulting engineers for this project in 2019 for the design development and the eventual appointment of the contractor and the contract management. And the tender documentation were finalized earlier that year in 2021. And the construction contract with the main contractor was signed in 2021 for the construction works. And then construction work started in earnest. Now, if you know the Western Cape, you know that if you start construction works in the middle of winter, you may run into some problems. But our contractor managed to deal with that quite efficiently until the building started taking shape and coming out of the ground. These are the plant rooms for the mechanical and electrical systems. And they reached a point where we could install some equipment. This is the main water cooling system, as well as the rotary UPS system. This is a bird's eye view in the foreground of the new plant rooms. And in the bottom left of the picture, the new waste management building that was constructed together with the large emissions stack tower that was erected towards the end of the project in the foreground. So this is what happened on the outside. Inside of our building, we also had a lot of things to deal with in terms of where the equipment had to be installed. First, we had to decommission and remove some redundant equipment. We had to partially demolish some of the support structures for that, and to make sure that the room is ready for all of the modifications and the new installations that had to happen. Quite messy affairs until we reached the point where we could start to install some new services, and we poured lots and lots of new concrete. to make the center vault ready for the resting place of the cyclotron that you saw earlier in the presentation. So this you will see in person with all of the nice equipment installed in its place. So the fourth work package, these comprises systems that we developed and built and manufactured in-house. It includes a sweeper steerer magnet system and power supplies for final beam control, the safety interlocking and vault clearance system, because these are radiation-controlled environments, personnel safety and environmental safety is of critical concern to us. The radiation monitoring services we did in-house, the control and automation systems and specialized hardware for the target stations and the target transporter were built in-house, and the water cooling manifolds and beam collimators for the target stations were completely manufactured and produced in-house by our team. And at this point, I would like to give a special thanks to my colleagues, many of whom are in the room, who contributed to this aspect of the work and to many other elements of the project. Thank you. So the fifth work, the last work package, as I said, because we use equipment that produces quite intense radiation, both gamma and neutron radiation, as well as the fact that we handle radioactive materials. These are all subject to regulatory compliance, and therefore this was quite a critical and important element of our job, is to make sure that we have all the licenses and permits in place. So we were granted the license to import the equipment from the Department of Health through SAPRA back in 2018, and we were awarded the license to install the equipment in November of 2020. And in March of last year, we were granted the license to keep installed and to use the new facility. So also a vote of thanks to our colleagues who were involved in that process. Now, I mentioned earlier that this all is phase one of the process leading up to the production of our final products for radiochemical and radiopharmaceutical applications. There is a phase two of this project that we envisage. Its objective is to establish new infrastructure for advanced nuclear physics research activities and new radioisotope product development. And we are currently in the concept phase of planning for establishing an electron-based photonuclear neutron source, and it could have applications such as a demonstrator for direct production of very short-lived radioisotopes, as well as radioactive beam production for advanced research into rare or unstable isotopes. So with that, I thank you very much for your attention.
Thank you so much, Dr. Leroux. And I'm sure, Minister, you know by now that when entities mention phase two, there's a hint there somewhere. Thank you so much. We're going to move on to the next two presentations. Are going to really talk about the application and the relevance of the products of this infrastructure that has been described here. But before perhaps I do that, I just wanted to quickly introduce the new Managing Director of iThemba Labs, Professor Victor Chivas, if you can just rise and wave. Thank you so much. And also we want to just express and indicate our gratitude for the previous Managing Director, Dr. Faisal Azayez, who's not here today, who spearheaded and chased the vision of the realization of this project. So, thank you. So next up is Dr. Deidre Prince, who's the head of the nuclear medicine at iThemba Labs, who's going to take us through quite quickly the process of the production and the relevant products and their application. Thank you.
Good morning, Honourable Minister. Good morning, guest. I'll just give a very brief overview on the department that uses this very specialized infrastructure to produce isotopes for medical application largely. Sorry, I don't know. I was instructed, but it's not quite happening. Okay. Can someone come and help me? There you go. Okay. So I'll just present a few of our key objectives, the department's key objectives, our production processes, some developments that we are currently looking at, our product portfolio, and then finally the distribution of our products both locally as well as internationally. Our key objectives are largely to utilize this available beam time for radioisotope production and to provide a reliable supply of radiopharmaceuticals and radioisotopes to both the local and international markets, hereby also increasing our export revenues and to maximize production efficiency and reduce occupational risks. The research, we have to drive research projects which support new product development, increase human capacity development, particularly in the nuclear sciences, and to strengthen existing and build on new collaborations. Also, we have a marketing, sales, and distribution plan which we need to strengthen and implement. Just running through some of our production processes, it all starts with the target irradiation. Hereafter, the target is transported in a transporter system remotely to dedicated hot cells where the target is processed to produce the desired isotope. After this, the radiochemical is transferred to the clean rooms dedicated for isotope, and where we prepare the final dosage forms. We do the following: we produce capsules, we produce APIs, injections, oral solutions, and radionuclidic generators. Throughout the process, we have quality control measures, and also to release a product, we do quality control on the final product before it's released for packing. Hereafter, while it's packed according to very precise IATA regulations, given the nature of the product, and hereafter it's transferred and shipped by road and air. Some of our other developments that we are currently busy with and that we plan for the future is new target development for increased production yields. We need to look at hot cell upgrades to accommodate these hotter targets. Sorry, when I say hotter, I mean more radioactive targets. And then also to improve in the hot cell storage, the hot target storage. And then finally, just a general facility upgrade. We have a number of radioisotope products that are produced for the local as well as international market. And it's largely, as I mentioned earlier, although we have some research application and industrial application, we also largely use it for medical purposes. So our generator, our germanium gallium generator, due to its half-life, fortunately, we are able to export this. This is largely used for the diagnosis of neuroendocrine tumors. But I'm also happy to say that this product is increasingly being used by our local nuclear medicine facilities. The I-123 products, these we also the only national producer of it. And once again, due to the shorter half-life, we are only able to produce and supply locally. FDG, very short half-life, as most of you would know, it's only 109 minutes, and this is for the Western Cape market largely. Then the strontium-82, we supply these to one of our clients, which we are happy to say is present today. We supply them as irradiated rubidium targets, and it's processed for the process there for the production of strontium and rubidium generators that's used for perfusion studies, myocardial perfusion studies. Finally, the sodium-22 solution and sources. These are for research purposes, and we are the only international producer of this at this point. Then in terms of new product development, this is not a comprehensive list, but this is where our focus is currently. We're looking at alpha emitters for targeted alpha therapy for cancer treatment. Primarily, we're looking at the astatine 211 and actinium 225. Hopefully, Prof. Mike will give us some, lead us into that discussion. Then in terms of theranostics, which is a combination of diagnostic biomarkers and therapeutic agents, we're particularly looking at the scandium and copper pairs. Then finally, in terms of our local radiopharmaceutical sales and distribution, we distribute to more than 55 nuclear medicine departments locally, and this figure actually also includes Namibia. In terms of patient numbers, I think Leroux touched on that, but my next slide will also touch on it. So globally, these radioisotopes now include the radiopharmaceuticals, but we have 75 local clients. These include nuclear medicine clinics as well as universities. We have 100 international clients, and this is growing. And then, as was mentioned previously, in the previous financial year, 165,000 patients benefited from our treatments, or our products, sorry. Then I think maybe this is an opportune time to thank the team and support team behind all of this, a very dedicated team, and thank you.
Thank you, Deidre. So just to illustrate, this last talk was outlining to us the production process. But I think one of the things that's important is how the investments that government makes in the national science system get to become joined up. So the iThemba Labs is a national research facility, but as part of the Department of Science and Innovation's South African Research Infrastructure Roadmap, there are a number of research facilities and platforms that have been established. And in this particular case, we wanted to illustrate this joining up of these investments in order to achieve an even bigger impact, so that there's articulation, there's connections for greater impact in society. So next up is Prof. Mike Sateche, who is the head of nuclear medicine at University of Pretoria, and is also head of the nuclear medicine research infrastructure, which is part of the South African Research Infrastructure Roadmap. Prof.
Thank you so kindly, Chair and Deputy CEO of NRF, to the Minister, DG, to the Chair of the Board of NRF, to the CEO of NRF, and the colleagues and the new Director. Really, I'm excited that we can have this talk today. I want to say that the nuclear medicine community is very, very excited, Minister, that we could have this opportunity to really be here at the launch. We are speaking chiefly saying that, of course, we are speaking mainly about cancer, but actually this facility here addresses the burden of disease in the country, from cancer to non-oncological applications to the oncological applications, and of course to infection imaging. As you can see, all of these images that I'm showing here, actually, the imaging thereof, it has been done with the gallium generator from here. This is speaking about a South African product. We can actually be able to see how the myocardium is going to have issues of the clots. I'm not sure if it can point. Oops. If it could point well, I mean, in this particular instance, that would be clear to show some of the calcifications that could happen with the gallium imaging. Of course, I'll speak briefly about the cancers that are here. And indeed, infection imaging, I'll show a slide briefly about what we can do, which is here. As you can see now, in this particular instance, that not only am I going to show you something that is clear about the prostate cancer, but for breast cancer imaging, we are doing something that is very critical and important. And thanks again to the product that comes from here. And of course, cervical cancer, we're making inroads. We have several PhDs that have already been coming out of this using the isotope from iThemba Labs here. And then, of course, HIV, a little bit difficult, but we're going there. And importantly, we have made strides in tuberculosis utilizing this, and that's very important to see that. Yes, the biggest is with prostate cancer and neuroendocrine tumors and other cervical cancers. So we are saying that there is a problem of alpha therapies. Deirdre has mentioned that there is alpha therapies that they're going to produce for the future. To be an expert, you must be an expert about the future, of course. And then, of course, for this effect, really indeed, alpha therapies, that production, it's a problem. And iThemba lab, SAIF, actually is the solution to this, to try and make sure that we do have the balance. You know, this is clearly an example of cross-disciplinary creativity that comes out of here. But this is where Africa is really going to take a lead and is taking a lead, Minister, in this regard. People speak about disruptors, but radiopharmaceutical are a serious disruptor, actually, in terms of cancer therapy. And I'm sure, for instance, I've seen the VC of VITS. He will know about this clearly. I mean, this is a serious disruptor indeed. And of course, cancer will never, ever be managed the same because of radioisotopes. Cancer will have less toxicities because of radioisotopes, and that's an important aspect. So, but for you to treat cancer well, whether you're going to use nuclear medicine treatments or any other treatment, you must image it first, and because you have to know what you are doing. And of course, this just demonstrates that indeed, just by mere imaging, you actually can reduce so many millions of deaths, unlike if you just treat without imaging. So it means you can have miscalculations in your treatment. So that's very critical, that imaging is very much part of this, and that imaging comes from here. Now, an example again of an iThemba lab, a SAIF product, is that conventionally you would image with a bone scan, saying this prostate cancer patient is okay, doesn't have many metastases. But you can see when you take a gallium generator and label it with what we call prostate-specific membrane antigen, how the same patient has been underestimated, all of the black dots, or rather the pinkish metastases. So it just tells you clearly that indeed, this is how conventionally you treat the patient, and you let a patient have a false sense of hope or really be not properly managed. And hence, look at the disruption that happens. And we have demonstrated that in 50% of the patients, you will change what was the intended treatment because of actually knowing where and how to treat it, and that's very important. So various examples of many patients that are riddled. Many of these patients would have been written off, that really they wouldn't be treated. They wouldn't be living long, but these are different patients, but all of these patients we get to treat, but you must see first what is happening. So this is an example of showing how it's really sustaining life. Proudly from the country here, that we could demonstrate that patients could live 4 or 5 years, that normally they would actually live below a year. And of course, that is the issue of what we do here in terms of South Africa. Just to give, again, classic examples that normally when you have metastasis in the lungs, you wouldn't treat them with external radiation, and chemotherapy might be difficult, but you can see before and after therapy that this actually is really something that you eradicate without any doubt. Then the patient lives much longer. Usually in the brain metastasis, again, that gets to be eradicated. That is the combination of what we call using a molecule to treat, to diagnose, and to treat. So using gallium-labeled vector and then treating with an alpha emitter such as actinium, which actually does the vision and mission of iThemba lab. And then, of course, in this regard, Minister, and the NDG, we hope that you will be accompanied by most of you when you're going to open what you have invested at Nuclear Medicine Research Infrastructure. You have made a huge investment, over 400 million, that is going to complement this facility. And of course, we have to see the results and the product of this. And the DG of DSI as well has been asking about the opening of this, but we hope that the colleagues here will be coming so that they can actually see the complementation, because really, clearly, that really, it completes the circle of what we need to do, and really that works out nicely, Minister. Just again, second last slide, you can see again demonstrating a patient that has got metastasis all over, stretchered living, and this person living over 3 years. This is really, I think, as we said, it's a clear disruptor of nuclear technology. But doing that, being targeted, remember we're labeling it that goes to specific cells, and it spares the normal cell, the normal organs to some extent. Yes, there will be some side effects, but they are manageable. The quality of life is improving, and the survival is improving. And that's an important aspect. And just now, you mentioned iodine 123. This is what we are busy with. Some of the cancers, they have resistance to chemotherapy. We can actually take your iodine 123 and label it with a BRCA mutation and see on a breast cancer patient that this person expresses this. Therefore, you can then treat with something like oliparib, which is an expensive drug. You wouldn't just give it to all the patients. You need to actually see it first. And that is feasible, that is possible. Yes, we are going to make some inroads in theranostics of breast cancer, and then that will happen, of course, together with SAIF in this regard. So one coming to a conclusion says that SAIF, nuclear medicine research infrastructure, and the community and researchers are very excited. We have produced, I think, almost all of our PhD candidates, Minister, they have been because of using gallium. I don't think we have produced any without utilizing gallium recently. So we, as we're saying, you must, oops. You must lift us to rise. And I like what Bongani has said clearly, and which is what we are doing. And in doing that, you have enabled us, again, to be a South Africa, the lead in the world. We have won several awards in global meetings. We have had our work being cited as featured in leading journal articles. And then, of course, I'm sure iThemba Labs is not aware, but I mean, clearly we are thankful to this effect, and we're looking forward to our collaboration even be more, and we will actually make South Africa proud. We are saying that as South Africa, we are one of the few that can have something like NUMERI, SAIF, and NTP. We have the entire cascade of nuclear medicine that we can do and target the therapies. We can start from drug delivery and go to approval. And then, of course, we will be able to influence global curriculum and the manner in which cancer is managed. Thank you.
Surely, DG, with all of that, the couple of zeros on the correct side of the decimal point are important. Without much further ado, Honorable Minister, we would like to call upon you, and I will not read the CV. I was told that we'll be here, and you'll be here for 2 days. Thank you. Over to you, Honorable Minister.
Oh, I see. There is a trick here, because we've had quite a healthy mix of tall people and not so tall people. Don't ever say short people. There are no short people. There are only not so tall people. Thank you very much, Program Director. Let me also, with the Deputy CEO of the NRF, let me also greet our DG, Dr. Philip Mjwaha, the Department of Science and Innovation. Mr. Yabo, I see you here as the member of our Portfolio Committee on Higher Education, Science and Technology. I'm told the Portfolio Committee is still a bit behind. Professor Musamo Shabela, the chairperson of the NRF board, and Dr. Fulufelo Nelwamondo, the CEO of the NRF, Dr. Chibase, our brand new managing director of iThemba Labs. I also hear that there are a few VCs, DVCs, deans, and other leaders of the Department of Higher Education and Training who are here with us. Let me greet them as well. Distinguished guests, members of the media, all protocol observed. In case I miss some very important and distinguished participants who are here, ladies and gentlemen, I must say I'm actually quite bowled over by what I've just heard this morning. I don't know what will happen then when I go and see. You know, I always tell the president that there is one thing I will attribute to him that he did to me. He taught me to be a negotiator. He assigned me to negotiate the education clause in our constitution. I was tasked with that, for the ANC, of course. But now I'm telling him of late that the second thing he has done to me was to deploy me as Minister of Science, because I have just honestly discovered the extent to which South Africa has got really and truly advanced science and distinguished scientists who are recognized worldwide, perhaps more than we do as South Africans. What we are launching here today is really something that is very important, which gives us hope. As we say, iThemba Labs. And does what we say as the Department of Science and Innovation, making sure that it's possible. I like to quote this of making sure that it's possible, together with my favorite quotation from Nelson Mandela, our founding president. It always seems impossible until it is done. It's my favorite quotation. And I think all that captures what we are doing here. The inauguration of this facility, the South African Isotope facility, forms part indeed of my department's effort to enhance our existing scientific infrastructure and to advance and foster technology development and innovation in nuclear sciences and technology for the benefit of society. I should have greeted Professor Leteche. I'm very sorry. Is it? Leteche, sorry. Because you gave me also just, because I was curious, who uses all this that we are trying to do here? You know? I'm actually quite impressed with what you are telling us. Let me just tell this story, Ishmael, because I know you're going to say now we have written the speech till 4 a.m. Then I start going all over the place. That's the advantage of being a minister, unfortunately, for you. My dear wife was a sister tutor, was a nursing sister who became a sister tutor at McCord's Hospital, those who know it, in Durban. So when the ANC got unbanned and other political organizations, they were drawn into what was called the ANC Health Committee in 1990. And she was working very closely with the late Minister of Health, Dr. Manto Shabalala Msima. So one day she gets onto the aeroplane, she finds the minister sitting there. Say, yeah, Pumelel, we are leaving me alone. I'm being slaughtered on this HIV and AIDS matter. And all of you that were in the health committee with, you are silent, you are quiet. Then Dr. Msimang continues to say, I know you can criticize me about my beetroot and everything, and that we are not moving fast enough on providing ARVs. I was also amongst those who was critical, by the way. But he says, you know what? You'll remember me even when I'm dead. You want me to take all my money, invest it into ARVs, and I have no 1 cent to research cancer in this country. And cancer is going to devastate South Africa. You will remember me even when I'm dead and gone. You know, as I'm sitting here, I'm thinking of this. You know, of course, we could have criticized the minister, like ministers are criticized, myself, I am as well, for everything. But she had a point in what she was saying. And I think what we are doing here with the NRF, as I say, really gives us hope. I know that the prof says it's not only for cancer, it's for a whole range of other things that you use the isotopes. But for me, I mean, my DG knows. I've said, DG, I think that as South Africa we have capacity in the end, maybe we may be the first to develop either a cure for cancer or effective preventative or arresting, early arresting, let me put it that way, of our cancers. Now, this NRF iThemba Labs research facility that has, since its inception in the 1980s, distinguished itself by producing world-class research and development in accelerator-based sciences and technology is, of course, a wonderful facility. There's a Dr. Bongani who phoned this morning on SAFM. I don't know if anybody else heard this. Who was very cynical about this. You know, he was following on our advert on SAFM and say, we need to be using other technologies and so on. DG, if you can go and get that clip from SAFM, because I think we need to answer him, not roughly, but also say, if we have got other ideas as the Department of Science and Innovation, we are open to those ideas. Bring them here, let's examine them on what they are. Now, this accelerator then is clearly the premier atomic particle accelerator laboratory on the African continent and also, I'm told, in the Southern Hemisphere. It's become a hub for vibrant research, development, and collaboration network for nuclear sciences that also I'm proud it includes our universities, research institutions, and international counterparts. This DG underlines now the importance of what I've been pushing, that we do need funding facilities for what I call an African research agenda. This is very much part of an African research agenda in terms of production of isotopes, further research, and human resources development. Now, the workforce of NRF iThemba Labs, of course, is the separated sector cyclotron, which was commissioned in 1985 to provide accelerated particle beams to 3 user groups for basic research, isotope production, and particle therapy. I also, of course, hope, Professor Mashabela, that as we do this stuff, we don't abandon basic research. I am a great proponent of basic research, and theory, by the way, because that's always the foundation for further development of what we are trying to do. I am not going into, because this thing has been, the SAIF has been explained very eloquently. I'm not going to pretend. In case also start biting my tongue, and you don't say a minister is biting his tongue, you say the minister was really floating, you know, and talking about all these sophisticated things. One of the most valuable lessons we learned from the advent of COVID-19 pandemic was that the capacity to produce our own medicine is extremely vital for our national response to the outbreak of pandemics. One of the things I would like us to do in this country, whilst I'm still minister for the next 10 months or so, we will not do it in 10 months, but if we can lay a foundation, is really teaching the development of, as I have said, a multidisciplinary program for the study of pandemics. We have entered the age of pandemics. Now, NRF, I can see they are listening to me. I didn't mention this last night when we were discussing this. I really do think that we need a multidisciplinary center for the study of pandemics, since we have entered the era of pandemics. And the African continent is quite capable of doing that, not just for the African continent, but for the world as a whole. I am now absolutely convinced, just also looking and listening to what was being presented here. It is one of a few places in South Africa, where the complete manufacturing process to produce medicine, specifically medical-grade radioisotopes, take place. This includes, as it has been said, production facilities, chemical processing, quality assurance and control, filling and packaging under sterile conditions, as well as end-to-end logistics, marketing, and sales. The entire value chain almost in this sphere. These isotopes that are produced according to good manufacturing practice in specialized facilities are used in a variety of instances, which I am not going to mention as they have been mentioned, and that these products are being delivered throughout South Africa, Namibia, and the whole world. Not too far from the Union Buildings in Pretoria, in the Sfako Makgato Hospital in Ga-Rankuwa, radioisotopes are used for better and precise diagnostic in cancer patients, as Professor Setege has said. I would like to say to my Chief of Staff, we've been challenged, DG, to go and open that facility. And indeed, let's commit to that. And all that we are short of is a date, Prof. We must do that because we have to understand completely what we produce here, where does it go to, and what does it do. You have, of course, noted from the earlier presentation that the NRF iThemba Labs is one of a few facilities in the world that produces the kinds of products that we are producing here. I was saying to Professor Mashabane, I'm more used to precision manufacturing, the idea of precision manufacturing. To me, this looks like precision medicine. He says, indeed, yes, we do talk about precision medicine. So, okay, you have helped me then to understand better what also we are doing here, which is something that is very important. Now, I'm no longer going to complain a bit, Dr. Nelumondo, that 40% of my budget goes to the NRF. Because I always say, gee whiz, this entity is so lucky, it takes 40% of my budget. Well, I can see today part of the justification of that. But you pay a price for that. You pay a price for that because once you do well, then you can't drop the ball. Not even a bit. NgesiZulu, I don't know how you say this in English, if you do well, we expect you to do well all the time. Those who do badly, we can afford sometimes to even ignore them. But say those who are doing well, you shall continue. 1% drop, you are in trouble. Now, I do want to say that this unique South African capability also ensures security of supply for the local nuclear medicine community and positions this facility well as a global competitor. The drive to ensure that the availability of a research infrastructure platform that supports cutting-edge research and the development and growth of technical competence in and for South Africa prompted the strategic integration of the infrastructure renewal at iThemba Labs in 2017. Now, I want to offer this. What are the human resource challenges and shortages do we have in order to take this forward as a country? I offered DG yesterday. Where is Thembi Safutshane, the acting DG? There you are, of DHET. The National Skills Fund will have to go a long way in funding that gap in terms of producing the human resources capacity that we need in order to fully realize the potential of a facility like this. That's a commitment I'm making. Now, the establishment then of SAIF signals the start of a strong research and development prospect for the future through the production of alpha particle emitting radioisotopes and other groundbreaking theranostic isotopes working in collaboration with local and international partners. These novel radioisotopes have the potential capability to target and destroy cancer cells, as we have said. In fact, Prof, what you showed there is amazing in terms of the capabilities of these radioisotopes, while simultaneously providing diagnostic imagery of the tumor. In my simple language from Dambuza, in other words, in order to treat cancer, now with the potential of radioisotopes, you don't have to go all over where the cancer is around. You now have to go straight to the cell. Am I right? To where it's located. That's simple language now. That's huge and important capabilities because sometimes when we talk about side effects, they derive from the fact that it's like we are searching in a forest, you know, as to where the problem may be. This is very important advancement and truly South African. You have mentioned the number of patients who are benefiting from this. I must say that I am really impressed. You can see now, Ishmael, that there's a difference in writing a speech before you hear and giving a speech after you have heard, you know? As Minister of Science and Innovation, amongst other things, I'm becoming innovative now, having heard what I've actually heard, you know? I'm also excited about the impact that this has made and will continue to make with regards to job creation and its support of local industry. I'm told the project will cost 590 million rand and will create 157 job opportunities, which includes subcontractors and provide 52 skilled and unskilled workers from local communities and 53 permanent jobs at iThemba Labs over the next 4 years. This may not seem much, but it's important for a country that is so much short of jobs and other means of sustainable livelihoods. In addition, which excites me even more, the project will offer a dedicated research program from which an estimated 21 postgraduate students per annum will benefit. The project is also expected to open huge opportunities to train the next generation of accelerator physicists, engineers, and technicians. And I must say also that this project, the SAIF project, positions NRF, iThemba Labs, and South Africa as a world leader in the real-world application of innovative science and technology for the benefit of mankind. I must tell you this short story. My DJ, Dr. Mjwaka, has the habit of taking me to all these places saying, you are not a full Minister of Science unless you have gone to the SKA, for instance, you know, and many other places. So he takes me to Washington, D.C., to this place called the National Institutes of Health. I'm sure most of you know better about that than me. So when we visit this place, the head, acting head, drops everything to hear that there's a South African Minister of Science who is in the building. So he comes and sits with us. He says, I really want to confess today, and I'm pleased I'm telling you directly. We apologize for having punished South Africa for having identified the Omicron variant of COVID-19. Yes. He said, that led to saving more lives in the United States than anything else. Had you not identified that, we could have been worse. Apologies for having tried to isolate you and say you are now carrying another dangerous variant, you know, and so on. I reminded them, did I, DG, of what my US friend always says that, you know, what some of the developed countries were trying to do with COVID-19 is to say, if they provide vaccines for developed countries, then they will be fine, and the rest of the world can see to finish. So this American friend of mine, he says, how stupid can some people be? Because it's like we are all in a swimming pool, and then we say, that corner of the swimming pool, we reserve it for those who want to pee. And we won't be affected, you know, the rest of us. Now, I'm using this because I'm just illustrating, really, the capacity that we have as South Africa for science. Now, this will not only improve our international standing through our research outputs, but will also strengthen and enhance our collaborations with similar research facilities abroad. The World Health Organization predicts that cancer will become the leading cause of death on the African continent by 2030. With available data, it is estimated that in 2020, almost 110,000 new cases of cancer were diagnosed in South Africa, with more than 56,000 cancer-related deaths, representing a quarter of premature, non-communicable disease-related mortality. This significant cancer burden is predicted to increase in the coming decades, with the incidence of new cancer cases expected to rise to 138,000 and 175,000 in 2030 and 2040, respectively. Cancer-related mortality is predicted to rise to 73,000 and 94,000 during the same period. The 5 most common cancers in South Africa, I've learned now, Prof. I've learned now, because I'm a Minister of Science, I can speak with such confidence that if I'm not in South Africa, they will say, wow, there goes that cancer specialist, you know. The 5 most common cancers in South Africa, I learned, in order of incidence, are breast, prostate, cervical, lung, and colorectal. However, of these 5 cancers, the leading cause of cancer-related mortality is lung cancer. Among women, although breast cancer has at least a 25% higher incidence, cervical carcinoma is the leading cause of mortality. This reality, therefore, underpins the need for the continent to provide access to the required radiopharmaceuticals and diagnostic infrastructure. This facility we are opening today is one of such efforts that we are putting as South Africa to deal with the prevalence of cancer in our country. And indeed, in the region, in the continent, and a contribution, I have no doubt, to science globally. In conclusion, I have no doubt that the South African Isotope facility has the potential to reposition iThemba Labs and South Africa as a world leader in the real-world application of innovative science and technology to the benefit of mankind. I wish to congratulate our entity, the NRF, and its management on this important milestone, and indeed also congratulate my DG and our department, and to congratulate all of you who have been involved in this. We do indeed look forward to more world-class scientific projects that are going to be produced by this facility. Thank you very much for inviting me to be part of this history-making event. Thank you very much.
Thank you very much, Minister. You mentioned 40%, but I want to ask you to increase it.
Oh,
So
okay.
I'm going to do public bribery.
Yeah, okay. You can see the height here, by the way, which says something.
So this is our small token of appreciation to you.
Okay.
You can open it,
Oh.
but it's up to you. Yeah.
Okay.
Thank you very much, Minister.
Thank you, Prof. Yeah, let me open it so that I declare with everybody Eerste present, you know, and no one will question and say, but I declared or didn't declare. Oh, wow, this is wonderful. And the portfolio committee, yes, they are here. They won't say that I haven't declared. Wow, this is very nice. The presentation. Thank you very much. Yeah. Sengehla, ne?
Okay, yeah. So thank you very much, colleagues. My name is Faure Nzimande, and I'm the CEO of the National Research Foundation. I'll be very brief. My job is very simple. It's just to thank all of you. But before that, I just want to make one small statement that indeed this project, Honorable Minister, is a game changer for South Africa. I think one can argue that is a game changer for the continent and for the greater part of the world. So indeed, with this game changer that we have in front of us, I see this as a good testament of where science can be directly linked to impact in society, and that's what we're trying to do. This is, in my view, something that talks to that very big ideal that we wanted to always have, where we want to say to our communities, to our people, that stay one more day without getting your 350 rands grant, because we are putting the money in science, which is going to make impact in your life directly. And they must be able to then say, wow, it's, you know, I can suffer hunger one more night, but science is working for me it makes me live longer. And this is exactly what this does. So with this, I just want to thank the Department of Science and Innovation for the investment that has been made through this project. It really makes us to be proud of being South African, of being in a facility such as this. We really feel honored that we are given an opportunity to make impact directly through science. Of course, we want to also thank all the key stakeholders, National Treasury, the ministry itself, and the NRF board in particular, given that when we started investing in this project, we did not have all the funds. This is a project that costed more than 600 million rands, Minister. We didn't have that money. But due to the vision of the board, they agreed in us putting money that we did not have into building a facility of this nature, which then makes sense. So I want to, I'm not going to thank all of you one by one, but I think your work has been amazing. I want to thank the previous managing director, including even the former VC, or rather the current VC, or the former MD of, no, you're not former, the former managing director, Zebulon Vilakazi, who was the managing director for iThemba Labs, who's here. But in particular, I want to thank Faisal Aziz, who is not here, who was the managing director, under whom much of this work really took shape. So thank you very much as a community of science, community of physics, community of engineering, community of nuclear medicine scientists. I think this again is a project that shows how various elements of science could come together to address a particular problem in society. And that's what we must be doing. We are ready to make this impact in this form going forward. So for me, I just want to say thank you, everyone, and all protocols observed. Thanks to the stakeholder community. We really believe that this is just an opening of new partnerships, even starting from today. So I'm inviting all of you to say, let's work together going forward. Let's make this facility to become a very useful facility for the country, to become a very useful facility for the continent, and in particular to address all the big problems that the country faces. I want to thank everyone, and I would like to also thank the program director for today, the Deputy CEO, Dr. Clifford Ngomani, who has directed our program as we are moving towards the end. And I'm going to ask him back to come to the stage and give us the way forward in terms of how we are going to move towards the facility without wasting any further time. So thank you very much, colleagues, and we really appreciate your presence here.
Thank you so much. And thank you, Minister, for all of those promises. Yes. So what we're going to do now is going to get the true and proper safety briefing. Philip, where's Philip? If you could just come forward and just give us a safety briefing with regard to, given the nature of this facility, and then immediately afterwards we will explain the logistics of what's going to happen next.
Right. Honourable Minister, distinguished guest, before we embark on the tour, please allow me a moment just to point out some occupational health and safety and also radiation protection requirements and hazards, of course. In the event of an evacuation alarm going off, please follow the evacuation route markers. They will direct you to the nearest assembly point. Should you be feeling unwell, we have a group of trained first aiders and occupational health clinic on site. Just notify one of the iThemba Lab staff members and we will assist you. Then I want to draw your attention to warning signs. Especially our tall guests, take note of the overhead hazard as you enter the vaults. As you traverse along the labyrinths of the vaults, there is an overhead hazard, and that is due to space constraints. Then you will also be visiting a radiation area. Please obey all the radiation safety signage. Pay attention to the local rules signposted outside of the radiation areas. The controlled area status is depicted by machine safety lights. Green is okay, it is safe. However, note, access is prohibited for pregnant individuals and also individuals with pacemakers. The radiation area has temporarily been declassified, and that is because the dose rate in the area is in line with natural background radiation levels. And the target station vault, the TS vault, is currently in the cold commissioning phase and therefore also not controlled. And then the last health and safety tidbit, due to space constraints in the vaults, in the controlled areas, guests will be accommodated in small groups of 20 to 25s, and you will be escorted by senior radiation protection personnel. Thank you very much.
Thank you so much. I was assured that all the machines that can make you glow in the dark have been switched off. In terms of logistics, as you will see on your label or on your name tag, there's colors that have been allocated. So what we're going to do is to
the new South African isotope facility. And we'll ask the minister to do the honor for us.
Okay, so let's check which way are we going to push it this way. All right, now let's make sure that all those with the cameras, real and fake, they are ready. So we're going to count up to, oh.
Just hang on a sec.
No, that's fine. We're going to count up to 3. Yes, yes. Oh, okay.
The South African facility officially opened by the Minister of Higher Education, Science and Innovation, Dr. Blade Nzimande, on 9th June 2023.